Hello everyone, welcome to another video on Snowflake related technology. Today we are going to build a serverless data stream or data pipeline on AWS platform, and this final data is going to be consumed in Snowflake. I'll explain the details shortly, but first let's look at what are we going to cover in this video. In this video, we will first have a quick overview of streaming data, then we will look at a few use cases, followed by discussion about the architecture of this demo and our data setup. We will create a multi-phase demo in which first we will create a Lambda function that creates S3 files from the incoming JSON payload. In the second step, we will create a REST API that calls this Lambda function. In the third step, we will connect all these to Kinesis data stream and Firehose that can throttle the data and control it as per our requirements, and this is going to be the most important part of this whole video. The world generates an unfathomable amount of data every minute of every day, and it continues to multiply at a staggering rate. Companies in every industry are quickly shifting from batch processing to real-time data streams to keep up with modern business requirements. In this case, we are going to build a data pipeline that can handle near real-time data stream, aggregate the data, and optimize the payload for Snowpipe to ingest into Snowflake. Some of the most popular use cases include an ATM machine generating data related to user transactions, a gaming console generating continuous user response statistics, hundreds or thousands of continuous prescription data related to healthcare, or application log data from an e-commerce site, handheld devices clickstream data, and finally, IoT devices generating continuous data using MQTT protocol. Let's look at the architecture of our today's demo and how each of these components of AWS are connected together to create the data pipeline. On the left side, we have data producers, and for this demo, I'm only going to use Postman, which will act as data producer. In the first step, we will create a AWS Lambda function that creates a JSON file on S3 bucket from the incoming JSON payload. It will neatly organize the newly created file with the date and time stamp based folders on S3. In the second step, we will create a REST API that has a public endpoint and sends the incoming JSON to Lambda function that we just created. We will call this API using Postman. There is a problem with this approach. This solution is going to create one JSON file for every record or every request that is submitted to the API. And these small JSON files of just a few KBs are not optimized for ingestion into Snowpipe. Ideally, we should have between 10 to 100 MB compressed files. How do we aggregate these multiple requests together to create one optimized file for Snowpipe? Welcome to Kinesis Firehose. We will add Kinesis data streams and Kinesis Firehose that will throttle the data and prepare it for Snowpipe and land them onto another S3 folder. So that's the whole architecture. Let's get started. I'll begin by creating a brand new S3 bucket. I'll call it as data stream. And I'll leave all the defaults. Someone has already taken this demo. All right, we got that one done. Let's move on to Lambda and create a new function, and we'll author it from scratch. We'll call it as process JSON data, and we'll choose Python 3.6. Okay, we'll leave everything else default. Create function. Okay, we will leave this as is. I'll just say here, instead of hello from Lambda, I'll say I have a couple of things I need to import. Let's import Boto3. This is Amazon's library that will help us connect to S3 and other services. We'll also import time. We're going to format the folder structure using this date and time. Then I initialize S3 as Boto3.client. Then I define my bucket name here, stream demo. Create a variable called stream data, and I will store the incoming JSON data that I got and convert it into UTF-8 format. And then file name, and file name will be the time-based file name. And next step is I create a JSON file with these contents by calling s3.putObject method, and the parameters for it is the bucket name that we have it here, and then key is file name, and okay, not file name, and then body is stream data. So this should create a file on our S3 bucket with incoming JSON payload. So let's test this out. So I save this and then I deploy this and then test it. While testing it, this is sample data that it is sending. For now I'm just fine with this. I'll just give it a name, and once I run this, it created, and I click on test. We got access denied error. Okay, let's fix this. So this Lambda function doesn't have permission to use S3 bucket, so let's give it the access. Create a role that will have all the permissions. Go to IAM. Let's create a brand new role called let's give it Lambda, create a policy, and we'll choose a policy called S3, and on this let's give it to everything. We're anyway programmatically using it, so on all resources let's give it only put object. So go to write and put object here. That should be good. Review and review our data stream policy. Create the policy. And I want to add something more to this. I'll also give it Kinesis so that we don't have to visit this again. Say additional services, Kinesis, and everything on Kinesis. Consumer all resources. But in your production environment, you want to give the limited permissions. Since this is for personal use, I'm just adding all of these that are needed. Kinesis analytics, all of it, and all resources. And save changes. And we should be good to go. No, so I'm yet to attach that policy, data stream policy. Next, and the name of the role is data stream role. Create role. So I got my role created, which has the policy, data stream policy. Okay, now I go back and change the configuration to reflect my new role, data stream role. There, save it, go back to code and test it again. There, this time file is created. Now let's switch to S3 and check if the file is created. Go to data stream demo folder. I see the file here, although it is not organized by folder structure. That's fine. Once we are further ahead in this, we can do that. All right, we achieved the first objective of the demo, Lambda creating a file on S3 bucket. So the next step is to add a API and call it from Postman, and it should also create the file on S3 bucket just like previously, and probably this time we can send some good JSON content, and we will also verify if that exact content went into the JSON file in S3. Okay, I'll go to API gateway and create a new API, REST API, and I call it as data stream API, and endpoint is regional, create API. I create a resource first, call it as data, just data is fine. And under that I create a method called post method, and this post method is going to call a Lambda function stored on US East, and the Lambda function name is, let's copy the name from there, process JSON data is the name. All right, we go back, paste it, save it, yes. Okay, so let's test it out, and we pass the data as okay, and test it. S3 file created, so looks like it's working fine. Let's look at S3 and check if it created our data. So 2126, yeah, this file, and download it. There's my file. So it is constructing the file. The API and the Lambda function is looking good. Let's test this through Postman. I go to API gateway, I need its endpoint, data stream API. I go to post, I say deploy it, so that I get a new stage called stage. I need a public endpoint to call it, so I copy this and I paste the URL. This is a post method, and in the body I want to send raw in the form of JSON, so I give it call method, send it, missing authentication token. I forgot the resource name, let's add that. And then instead of this JSON, let me put a proper JSON, okay, and call it. All right, the file is created. Let's go back to S3 and verify that again. This one. There you go, we got all the JSON. So now in this we have the title. We will keep changing that for our next test. For now we are done with second step. So let's review our architecture again. So this is what we completed now. We created API that is calling the Lambda, and that in turn is creating a file on S3, and we called it from Postman. So our next step is we will create the Kinesis stream and Firehose, and then we will change Lambda function to write it to Kinesis stream data stream rather than directly creating S3 file. Let's get started with Kinesis stream first. I search for Kinesis, go to that, and I first create a Kinesis data stream, call it as K data stream. Number of open shard, I just enter 1, which is more than sufficient for my usage. Create data stream. Okay, I have it, and then I select delivery streams. Go to create delivery stream for Firehose. I name it as K Firehose. Firehose, my source is going to be the data stream that I just created. K data stream is the name of that. Enable server-side encryption, I don't need to, so I will say next. And transformations, I don't have any transformations. I want the data to just pass through. Record format conversion, no, I don't want any of these. Next. And the destination, where do you want to store the output? I would like it to store in S3. So which bucket? Data stream demo. I will say Firehose Okay, so this will be my subfolder under which it will create YYMMDDHH format, and say next. This is where you mention what should be the maximum file size. In my case, 50 MB should be good. Depending on your use case, you can change it. And buffer interval, I want it to create file every 1 minute, so 60 seconds. So with this setup, what happens is if it receives 120 MB data within a minute, it will create three files, two files with 50 MB each, and the remaining 20 MB goes into the last file within 1 minute. If the file size is less than 50 MB within 1 minute, it will just create one file. If it does not receive any data in 1 minute, it will not create the file. So let's see other options. Do you want this to be compressed in any of these formats? I don't want it to be compressed because I want to review the file. And then encryption, I don't want encryption. Error logging is enabled. I can even disable this. Tags, I don't need any of those. Okay, I let it create this new role. And then I go ahead and create the delivery stream. Firehose as well as data stream is created. They should be ready to be used. So we created Kinesis stream and connected it to Firehose. Now I need to connect my Lambda function to it so that when we pass the data to it by invoking the API through Postman, the request should go to Lambda and that should send it to Kinesis data stream. And after a minute, we should see a file in S3. Even if we invoke the API 4 or 5 times within a minute, it should bunch all of them together into one file per minute. Let's update the Lambda function first and then test it again with Postman and then verify the files getting created. Okay, let's move to Lambda. And edit our Python code. I'll create another variable called stream name equal to key data stream. Yeah, that's good. So I create a variable called data ds for data stream equal to boto3 dot client of Kinesis. So now instead of this put object which was writing it into S3 bucket, I wanted to send the record to Kinesis data stream. So how I do that is ds dot put record, and here I pass stream name equal to stream name, this is my variable, and data equal to stream data, and partition key. That should send the record to the stream and hopefully it will create the final file. Let's test it out. Before that, save it, save and deploy. Yes, we can test it from here also. If it is good, it will just, yeah, it will not complain. Okay, it's not writing into S3, so probably let's change this message to, okay, save it, deploy it, test it. Now this makes a little more sense. So let's come back here and check it in S3 if it really created something. And if you remember in Kinesis, we mentioned that it has to write it in a different folder. We obviously don't see that. Refresh after a minute and you have your folder there. So your Kinesis Firehose is working and it has created this folder structure and a file. If I download it, it should have my test data, key 1, key 2, yeah. So this is working fine. Now let's test it with some good data. I go back to Postman and create a new payload with Indiana Jones as title of the book or movie. So let's send this. The next one is Mechanis Gold. Send it. And maybe Terminator. Send it. And maybe Man in Black. All right, that should be a good number of movie titles. So let's see if it aggregated the data. I go back there, get into this. This is my previous file. We'll just wait for a few seconds and refresh. There we have our second file, 1553. Yeah, this is the latest file. I open it. Open. There we have our Indiana Jones, Mechanis Gold, Terminator, and Men in Black. We have all of them. So that's it for the demo, and with this we have successfully created AWS data stream for Snowflake, in which we created API gateway, Lambda function, Kinesis data stream, and Firehose, which is aggregating the data that we are sending through Postman in our case, but it could technically be anything else also, such as data coming from IoT or your weblogs or your clickstream or any of the streaming data type. Now the data is prepared so that it can be ingested into Snowflake. For cost efficiency, you may want to look at the charges for Kinesis data stream as well as Firehose and all the benefits that it can bring in. You also need to consider the additional lag time that you may have for your Snowpipes data availability. Another related topic is, last year my son created a video for one of his project, which was passing the data from our Raspberry Pi using MQTT protocol, passing through IoT core and Lambda function. You could technically connect that data also to Kinesis effortlessly. Link is available in the description. If you have any questions or doubts on building your serverless data pipelines on AWS, do let me know. I'll be happy to answer. My social media links are provided here. Feel free to connect with me on those too. Thank you.